So probably one of the most important skills that you can have when it comes to exponents and logarithms is converting between them. So converting exponents to logs or converting logs to exponents. Either way, it's really important that you can do this very, very effectively if you're going to do well in the next couple of chapters, next couple of sections. So your book, just to let you know, does it in a way that I don't necessarily, well, it's not like a way to do it, but they present the problem like this and they'll say convert it to an exponent. I'm just going to let you know that I have a harder time doing it like that. I always like to have the log on the left. Log left, get it? Because it's an L. Log on the left. So I always rewrite it like this. And the reason I do is I have a very specific system. As I start reading it from left to right, and the first number I see is the first number I write down. So when reading from left to right, the first number I see is a 5, right? So I see a 5, so I write 5. Then I'm going to do a hop. The idea is I want to separate the 5 and the x. Right now the 5 and the x are next to each other. So I want to get them apart. So I'm going to skip over the x. I'm going to go 5, hop over to the 2. So that's the next number I'm going to write. And then I'm going to hop back to the x. So what I've really got is 5 squared equals x. I do, again, going from left to right, the first number I see is the first number I write, then I hop over, then I hop back. 5 squared is x. Now if you want, you can go ahead and say, okay, so that's x equals 25. But it's neither here nor there. We're really just not worried about solving too much. We're mostly worried about converting. So let's try another one. Say we had something like 3 equals log base x of 64. You do the same thing. I'm going to rewrite it so my log is on the left. And I'm going to read from left to right. As I go from left to right, the first number I see is an x. So I start at the x, I hop over to get the 3, and I hop back to get the 64. And that's really all there is to it insofar as converting logs to exponents. Do a couple more, get the hang of it. Say we've got log base 3 of 7 equals y. Again, reading from left to right, see if you can get it. Start at the 3. The first number I see is a 3, so I write a 3. Hop over to the y, hop back to the 7. And the 3 and the 7 are separated, and we can continue to make progress. It's kind of fun, right? Now, just so you know, you can do all sorts of crazy things with exponents and logs and converting back and forth. So if I had log base x plus 1 of y minus 3 equals 6, it's still the same thing. Reading from left to right, the first number I see is x plus 1, hop over to the 6, hop back to the y minus 3. Okay? So it's kind of neat because you can do just all sorts of crazy stuff with this, but I mean the point is just to get really good at knocking them back and forth. Now we can also convert them the other way. So instead of converting to exponents, now let's convert things to logs. And I mean it, you've really got to get good at this, because if you don't, you're going to be suffering. So say we have 12 squared equals x. I'm going to use my same strategy. I'm going to read it from left to right. And the first number I see is 12, so I write, oops, I got a little excited. First number I see is 12. So since I'm converting to logs, the first number I write is going to be 12. So the first number I see is 12, the first number I write is 12. Hop over to the x, hop back to the 2. So first number I see, I write the 12, hop over to the x, and back to the 2. I'm a big fan of the hopping method. It's fun to say, among other reasons. So 5b cubed is 8. See if you can get that one. So again, I'm reading from left to right. Log base, the first number I see is a b. I hop over to the 8, and then I'll come back and pick up the 3. Got it? You can do it with all sorts of stuff, even funky numbers. Reading from left to right. Log base, first number I see is e, and I hop over to the 9, and I hop back, and I get the y. And that's about all there is to it. Well, it's kind of fun. So we're going to do a quick review, an aside, if you will, to see how much of this you remember. so we've got this. Look at these kind of problems. 2 to the 8, 3 to the x, 2 to the x equals 8, 3 to the x equals 1/3, and the cubed root of 8 equals 8 to the x. Let's see if you remember how to solve these problems. Right. Now some of you might be able to just look at that and say, oh, that's x equals 3, because 2 cubed is 8. Fine and dandy, but just make sure that you know how to get this the long way. The long way. That's because if you get to a problem that you can't solve mentally, you'll have to solve it the long way. So 8, what you do, remember, is you say, okay, I've got a base over here. My base is 2. So I want to rewrite 8 as 2 to the something or other. So 2 to the what gives me 8? 3, right? So 2 to the 3 gives me 8. And that's focusing on this one. 2 to the 3 gives me that 8. Now that my bases are the same on both sides, I can equate the coefficients. I can equate the coefficients and say x equals. So that's kind of like the long way to do it, but it's important to know, just in case you're running through a problem you can't solve by hand. All right, same thing here. We've got 3 to the x. Now we've got to figure out, well, what does this x, this 1/3 mean? It's 1 over 3 to the 1. So how do we get 1 over 3 to the 1 in the top? How do we move it up? We do it by, we get rid of the dividing by sticking a negative in front of the exponent. Stick a negative in front of the exponent. 1/3 is 3 to the negative 1. Now that the bases are the same, we can equate the exponents, so x equals negative 1. Now finally this one, we've got this cubed root of 8, and this is when you need to remember that the cubed root of something, the nth root of anything, is the same thing as 8 to the 1 over n. This is an exponent law. So I say, learn your exponent laws, and you say, that lady is crazy, she doesn't know what she's talking about. No, I really do. It's actually important, because if you don't know your exponent laws, you don't get to come to any cool math parties. So since our bases are the same, it means we can equate our exponents. That is not my kid, so you know that. That means x is 1/3. Alright, so if you're not strong on these, you definitely want to go review this in the prerequisites chapter. Make some progress, because this is not, this is not something you don't want to be able to know how to do. That was a lot of double negatives. Sorry about that. Alright, so here's an example. Yeah, not mine. Hold on, I'll put this off for a second. Okay, I don't actually think it's going to get better. So, anyway, gotta have an example like this. I'm at Subway, in case you're wondering. Say I want to evaluate log base 2 of 16. Say, I don't know how, because I don't know my logs. You don't let me use calculator. That's true, but guess what? This is whenever you solve these problems, what you want to do is, if you don't have an x in the problem, if you don't have an equation in the problem, I guess that's what I should say, if you don't have an equal sign, go ahead and set it equal to something. Because if you set it equal to something, now you can convert it into an exponent. Okay? So we're going to read from left to right. Left to right. The first number I see is a 2. 2. I'm going to hop over and pick up the x. Hop back and get the 16. So now I have 2 to the x equals 16. And now we have something like this that you should be able to solve and get x equals 4. Okay? Let's try another one. So log base 7 of 1 over 49. And say again, alright, I don't have an equation, so I'll make it an equation. Say that equals x. Now I'll rewrite it as an exponent, reading from left to right. First number I see is 7. Hop over and get the x. Hop back and get the 1 over 49. Okay. Now we need to get everything in the same base. So I'm going to make my 49 into 7 squared. Right? Because 7 squared is 49. Now I need to get the 7 up top, and the only way to move it up top, the only way to get over that line, is to put a negative sign in front of the power. Now that my bases are the same, I can set my exponents equal to each other and get x equals -2. Good? Alright, so isn't this exciting? Yay! You're solving all sorts of stuff now you can never solve before. You should be very proud. Alrighty. Log base 25 of 5. And we're going to say that's x. Reading from left to right. 25 to the x equals 5. And alrighty. This one might give you a little bit of pause, because I'm not really sure what's going on here. But I always know that if I don't know what to do, I'm going to try to get everything into the same base. So I've got something that's in base 5. So I can turn a 25 into a 5, right? Because 25 is 5 squared. So I'm going to replace 25 with 5 squared. There we go. Like that. Now hopefully you remember that x to the a to the b is equal to x to the ab. That's an a. And in that case, that means that we can now say 5 to the 2 to the x is 5 to the, got it? You got it? 5 to the 2 to the x is 5 to the 2x. And then 5, and what's the super secret exponent up here? It's a 1, right? Not a 0, it's a 1. So now that our bases are the same, we can set our exponents equal to each other. Divide each side by 2 and get x equals 1/2. Alright? And that makes sense, right? Because 25 to the 1/2 is the same thing as, hopefully, the square root of 25. And that's 5. And that's what we meant it to be. Alright, we'll do one more. One more fun problem. Try. That's a terrible EX. EX. Say we've got log base 2 of the 5th root of 2. My word. Set that equal to x. Now reading from left to right, we've got, first number I see is 2. Hop over and get the x. Hop back and get that thing. 5th root of 2. Next step is to recognize when I take the 5th root of something, I really mean 2 to the 1/5. Now the bases are the same. So I'll set the exponents equal to each other. I should write a song about exponents. How much I love them. So there you go. Fun stuff, right? So what's really neat about this is you actually can solve all sorts of equations that you couldn't solve before, which is the whole reason that we invented logs in the first place.